Are you ready, kids? 5.3, factoring perfect expressions. We're going to factor expressions that are perfect today. And what I mean by perfect is they're either perfect squares or perfect cubes. Okay, so let's see. Let's do a little bit review first. Remember when you have x squared minus y squared, you can factor it perfectly with an x in each parentheses and a y in each parentheses, and then they're separated by a minus sign and a plus sign. Actually, the minus and the plus don't matter, which order comes first. For example, if I ask you to factor m squared minus 25, notice that m is a perfect square and 25 is also a perfect square. So you would factor it m plus 5, m minus 5. Here's another one. This one's a little bit more tricky. 9a squared minus 49. 9 is perfect, a is perfect, and 49 is perfect. And so that's how you would factor it. 3a plus 7, 3a minus 7. I just split the perfect in half. And then in the imaginary chapter with complex numbers, we did x squared plus y squared, and that plus sign does change a lot of things. It's still x minus y, x plus y, but then we have to have the imaginary I in there. All right, so let's do a few examples of those. How about 4x squared plus 9? 4 is perfect, x is perfect, and 9 is perfect. So when you split it up, you have 2x plus 3i and 2x minus 3i. Okay, here's another one. Perfect, t's perfect, and then I don't know if you guys know off the top of your head, but 625 is perfect. It's 25 times 25. There it is, t plus 25i, t minus 25i. All right, now let's bump up a level of difficulty. What about the difference of perfect cubes? So it has a formula as well. So when it's perfect cubes and the difference, so there's a minus sign. So when that happens, this is the formula. The thing you have to pay attention to the most is these signs. It's minus, plus, plus. Minus, plus, plus. All right. And then if you follow the pattern, it's just the x minus the y. And then it's the x squared. And then the x and the y together. And then the y squared. Okay? Let's try to translate that example to this problem. M cubed minus 27. You should recognize that the 27 is a perfect cube. It is 3 times 3 times 3. 3 times 3 times 3 is 27. So we can use the formula to factor. M minus 3, because this is the same thing as 3 cubed. So that's the 3 that we're looking at. And then it's the m squared, and then the m and the 3 together, and then it's the 3 squared, which is 9. All right, so that's how you factor those. Let's do another one. How about a w cubed minus 216? 216, what is that a perfect cube of? I think it's 4 times 4 times 4. Let's check. 4 times 4 times 4. It is 64, so it is not 4. Maybe it's 6 times 6 times 6. It is 6 times 6 times 6. All right, so there it is. W minus 6, and then w squared plus 6w. That's supposed to say w. Plus 36. All right. Let's go do the next one. The sum of perfect cubes. So when it's addition, it looks like the same formula, but it's slightly different. This one is plus and then minus, and then plus. All right, so try not to get confused between the two. Let's do W cubed plus 125. 125 is 5 times 5 times 5. That I do know. So W plus 5, and then the W squared, and then the W and the 5 together, and then the 5 squared. Okay, and the sign is plus minus plus. Another one, P cubed plus 64. 64 is actually 4 times 4 times 4. So P plus 4, and then P squared minus 4P plus 16, if we follow the formula correctly. All right, let's do some tricky problems, see how tricky they get. All right, tricky, two trickies. All right, let's see. 27 is a perfect cube. It's 3 times 3 times 3. 64 is a perfect cube. It's 4 times 4 times 4. But then how do we get the b to the 6 to be a perfect cube? Right now it's the perfect 6th power. But how do we get it to a perfect cubed? Well, there is a way. There it is. There it is, the 27 is just 3 times 3 times 3. But to get b to the 6th power, I split it up. So it's actually b squared to the 3rd power. And that's how you would change it to make it a perfect cube. And then, of course, 4 to the 3rd power is 64. All right, so to apply our formula, this whole thing in here is kind of like our x, and this right here is like our y. And so there it is. Let's see what that looks like. So it's 3b squared plus 4, and then 3b squared squared gives us a 9b to the 4th power, and then 3b squared with the 4, and then the 4 squared. And then we just have to clean that up a little bit. We just have to multiply the 3 and the 4, and then square the 4, and there's our final answer. All right, that was kind of tricky. Take a good look at it. Make sure you know what happened there. Let's do one more example for the day. Oh, just kidding, there's 2 more examples. Negative c cubed plus 125. So that negative in the front makes things a little bit tricky. So to avoid it, we can just pull that negative out. So pull the negative out in the front, it becomes c cubed minus 125. 125 is just 5 times 5 times 5. And there it is. Don't forget that that negative is still there, but now there's the rest of the formula. Okay, last one for the day. 3x to the 4th plus 24x. What can I pull out first? I can actually pull out 3x to the front, and I'm left with x to the 3rd plus 8. And then, of course, the 8 is a perfect cube. It's 2 times 2 times 2. Using the formula, I have the 3x that I pulled out, and then this part is the formula. X plus 2 times the quantity of x squared minus 2x plus 4. All right, go ahead and try the homework.